Alright, so let's get to where we actually have an application of using radians and degrees, and we're going to talk about linear and angular speed. And we're also going to talk about arc length. So if you're given a circle and you want to figure out how far is it around to a certain part of the circle. So if you start here and you want to figure out, well, what's the distance around that arc to go from here to here. What you're going to need to know is you're going to need to know what this central angle is. So if this is your little slice of pie, you're going to know what this theta is. You're going to need to know what your radius is, because we're not dealing with just the unit circle here. We're going to be dealing with other varying distances. If we have if we're using a tire, for example, and we're trying to figure out, well, what's the radius of a tire? Well, it's not just 1 foot necessarily. Tires come in different sizes. So we're also going to need to know, and then what we choose to represent our arc length is S. Now, very, 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 very important thing to know is theta must be in radians. If you don't write it in radians, number one, it's not going to make sense because you're going to be multiplying something by degrees, which doesn't make a whole lot of sense. But also, you're not going to get the right answer. So if we want to look at example 5 here, and it says a circle has a radius of 27 inches. So if we look at, here's the center, it doesn't matter where we draw the radius. Here we go. And this is 27 inches here. We want to find the length of the arc that's intercepted by a central angle of 160. So we'll say that, straight across would be 180. So we'll say 160, it's just a guess. This is 160, so your theta is equal to 160 degrees. We want to figure out what is the length of this arc out here. So this is your S. So we're going to use the formula S equals R theta, and we're going to plug in some values. Now, if we're trying to find S, we know our R is going to be 27 inches. Problem is, if you multiply by 160 degrees, that doesn't make sense. You're going to take 27 inches times degrees. That is a no-no, and there's going to be multiple people to do this because they didn't watch the notes. So tell your friends, don't even tell them to watch, because it'd be a lot funnier if they don't watch. So don't tell them about it. But you need to convert your degrees into, your 160 degrees into radians. So we need to multiply this by a pi over 180. And when you do that, well, your zeros cancel. You get 16 over 18, which is just an 8 pi over 9. And then, so this is your radian. So what you're going to do to find your arc length now, S equals 27 times 8 pi over 9. And then you just cancel out your 27 and your 9. That becomes a 1. This becomes a 3. You get 3 times 8 pi, which is just 24 pi inches. And that, my friends, is how you find your arc length. Cakewalk.